Hi, my name is Chris, and I live in Louisville, Kentucky. My fascination with pi has driven me to introduce you to its infinite complexity. I love pi, as in the ratio of a circular circumference to its diameter, of course. Pi has plagued the minds of mathematicians going back millennia, having roots in Greece, Egypt, and China. If you've ever taken freshman geometry, you may know that pi is approximately 3.14. Because pi is an infinite amount of random digits, it is considered an irrational number. The search for pi can be seen in the early dilemma that many mathematicians call squaring the circle. This is the process of creating a square with the same area as a unit circle, but there is a twist. You can only use a compass and a straight edge. The resulting square would have the side length of the square root of pi, also an irrational number. What makes this impossible was first proved by Ferdinand von Linnemann in 1882. Pi was not only irrational, but also a transcendental. A transcendental number is a number that is not a root of a non-zero polynomial equation, or in other words, cannot be expressed using rational numbers. The square root of 2 is irrational, but it is not transcendental. Because pi is transcendental, the square root of pi is also impossible to draw with a compass and a straight edge. While today we know pi to trillions of digits, many mathematicians throughout history have attempted to calculate pi. One of the earliest known estimations is from the Bible in 1 Kings 7:23. It estimates that a circle is 10 cubits across and 30 cubits around. A cubit, if you didn't know, is an ancient form of measurement about the length of your forearm. When you divide the circumference of the circle by its diameter, you get pi to be approximated at 3. Estimations of pi have varied across the world. For instance, Roman used 3 1/8, which is 3.125, while the Egyptians used 3 1/7, which is simplified to 3.143. What exemplifies the stubbornness of the Roman Empire is the knowledge that 3 1/7 is about 6% more accurate than the value of 3 1/8, but they refused to use 1/7 because 1/8 was much easier to manipulate due to factoring by 2. Consequently, many Roman calculations of arches and other circles could be inches off. A few centuries later, Archimedes of Syracuse calculated the bounds of pi to be between 223/71 and 22/7. His average value would be an amazing 0.8% off of the true value. He obtained these outer bounds by inscribing n-gons, or regular polygons of n sides, like hexagons and dodecagons, inside and outside the unit circle. Then, by calculating the area of the larger and smaller n-gon, he could deduce the range for pi. In his final calculation, he used a circumscribed 96-sided polygon. Interestingly, his efforts hadn't reached China by the 3rd century, but they were very similar to the ideas of Liu Hui, a Chinese mathematician who calculated pi to be 3.1416 by using a single 96-gon. He later used a 3072-sided polygon to check his calculations, which proved to be an amazing 2/10,000ths off of the true value. His calculations on pi were revolutionary, as the previous value for pi in China was estimated to be the square root of 10 by one Sheng Heng in the early 2nd century, which is 0.7% larger than pi. You don't have to be a mathematician to calculate pi, though. Georges Louis Leclerc of the 18th century proposed the idea of calculating pi through geometric probability. Say you have a piece of paper with lines that are t distance apart. Now you repeatedly drop pins of L length onto the board. After a certain amount of trials, you can calculate pi using this equation. Pi equals 2ln over th, where n is the number of pins dropped and h is the number of those that cross the line. Go and try it yourself. But why is pi so special? In order to do any computations involving circles, some value of pi must be used. You may know that pi is used for calculating area and circumference of a circle, as well as the surface area and volume of a sphere. But what's amazing about pi is that it is found in other disciplines as well. Can you guess any? What about in space? Astronomers use pi to find exoplanets in other solar systems. They first study distant suns, similar to our own, by looking for shadows across the sun, which could be planets that are in orbit around that particular sun. They can then use this shadow to calculate its radius, and then its volume, to determine whether or not it would be suitable for organic life. In this way, pi is being used to find other forms of life light years away from ours. Pi also shows up in the sky itself, though. Robert Matthews from the United Kingdom used the idea that the probability that any two random numbers share a common factor is equal to 6 divided by pi squared. Matthews monopolized on this principle by calculating the angular distance of the 100 brightest stars in the sky. He then turned these distances into 1 million random pairs. He ended up with an approximation for pi equaling 3.12272, which is 0.4% off of the true value of pi. Pi is not only found in the sky, it's also found here on Earth in our rivers. A river is always longer than the distance between its head and its mouth. As a river forms, any slight curve causes the water to move faster on the outside. This causes further erosion, resulting in an even further curve. This bendiness is often referred to as a river's sinuosity, and as it turns out, the average sinuosity of most of the world's rivers approaches pi, or they are, on average, pi times longer than their ultimate displacement. Behind me is the Ohio River. The Ohio River runs for about 1,579 kilometers, but its direct length is 879 kilometers, having a sinuosity of about 1.797. Pi doesn't show up only in our world, though. It also shows up in every living thing. We have DNA in most of our cells. In fact, we have about 6 feet of DNA in each nuclei. For it all to fit, the DNA must wrap around histone proteins. This wounding results in the DNA being, you guessed it, about 1.5 pi times shorter. Ultimately, though, pi has many uses in astronomy, natural sciences, and mathematics, and it appears throughout the world in various ways. But it is more to that to some. To Lu Chao, pi is a challenge. He correctly recited pi to 67,890 places to the Guinness World Records in 24 hours and 4 minutes. He did this by using the common mnemonic device of creating a story, where each word has a number of letters equal to that digit. Most stories made, however, are actually writers practicing a restrictive form of writing rather than mnemonic devices. For example, a poem by Mike Keith begins with 1, a poem, a raven, 31415. Even if you will never use pi in your life, you can still have a little fun with it. Pi is a transcendental infinite number, meaning that any and all possible number combinations can be found within. A website called angio.net allows you to input any number and find where, in the first 1 to 2 million digits of pi, that number sequence appears. Try out your phone number or even your city code. Just have fun with it. Hope I was able to interest you with pi as much as it interests me. You should go ahead and check out angio.net. And while you do that, I've got my own research to take care of.